Hey guys, and welcome back to our final week of class. It's hard to believe that we finally made it, but somehow, rather another, we're here. And so we're actually going to be finishing up this class with the respiratory system. Last week we talked about our blood and the cardiovascular system, and this week we're going to be looking at how that blood gets oxygenated in the first place and how it gets rid of the carbon dioxide which is needed for our bodies to function. And this all happens in what's known as the respiratory system, which is just how we breathe. So today what we're going to be doing is we're going to be looking at the anatomy of the respiratory system. And then tomorrow we're going to take a more in-depth look at the physiology of it. In other words, how it actually happens. And so here you can see we have a basic list of some of the different organs or structures within the respiratory system that we're going to be talking about today, including the nose, the pharynx, the larynx, the trachea, the bronchi, and then the lungs, which end in or are filled with these sacs known as alveoli. And we'll probably be talking more so about these guys tomorrow. So let's go ahead and let's just get started with the anatomy. So again, this is just showing you another diagram that's detailed structure about what we're going to be seeing. And before we even get talking about that, it's important to understand its function. And I briefly hinted at this earlier before we got to this slide, but its main function is just simply to help us with that transfer of oxygen and carbon dioxide. In other words, we would say that it's helping with the gas exchange between the blood and the external environment. That's just saying that we breathe in oxygen and we exhale the carbon dioxide. That oxygen, when it's in our lungs, it's in a high capacity, it's in an area of high concentration. It wants to get to an area of low concentration, that low concentration being our blood. Likewise, that carbon dioxide in the blood is in an area of high concentration, wants to get to an area of low concentration, which would be in the air sacs of the lungs so it can get pushed out. And so once in the lungs, it's just kind of this simple diffusion. But it takes a while to get there. There's a process for this air to travel down to and into the lungs, and then for that bad air to travel outside of the lungs. And so what we're going to be doing today is we're going to be looking at that passageway that goes all the way down to the lungs. And the whole way, as we're looking through, it's going to be doing three main things. It's going to be purifying the air, it's going to be humidifying the air. In other words, it's going to make that air moist and damp. So our lungs, or even just our trachea, or our different uh, areas within the respiratory system, so it doesn't dry out. And it's going to be warming that air. And that last part is also really important because we don't often think about it, but the air we breathe isn't always warm. In other words, it's kind of hard to think about right now because we're just going into summer. But think back to the winter when it was like 50 degrees out. And I know that's not really that cold, but for us in Florida, 50 degrees, that's quite a bit of a drop in temperature. So let's just say it's 50 degrees out. And you're outside because 50 degrees is nice weather to be outside. And you're breathing in that nice cool air. Well, what temperature should your body be? Your body temperature should still be 98.6 degrees Fahrenheit. However, if you're constantly breathing in this air that's at 50 degrees Fahrenheit, that's going to lower your internal body temperature, which is not a good thing. And so, our respiratory system has specific areas that are lined with different veins and arteries, these capillaries that are going to be close to the surface to allow for that heat exchange to warm up that air as it travels down the passageway to the lungs. And so we're going to see how it purifies, humidifies, and warms the air as it travels through. And the first place this air comes through is the nose. Now, the nose is considered the only externally visible part of the respiratory system. A lot of people may say that, well, what about the mouth? Because we breathe through our mouth. However, uh, like I said previously, this passageway is going to be doing three main jobs. It's going to be purifying the air, it's going to be moistening the air, and it's going to be warming the air. And while the mouth may do some of those things, it's not going to do all of them. And so it doesn't necessarily meet the criteria for being an actual part of the respiratory system in that sense. Yes, it is because we're breathing through our mouths, but our mouths have other functions as well. It's where we drink, it's where we eat. And so it's not made specifically for the respiratory system, whereas that's the main job of the nose is for respiration. And of course, we have the olfactory senses located at the top of the nasal cavity. Speaking of which, our nasal cavity is actually divided into a right and left nasal cavities by an area known as the nasal septum. If you remember from the last chapter, we talked about a septum is just a piece of like tissue or membrane that divides two areas. And so the nasal septum is no different. It's just going to divide the nasal cavity into a right and left. And so again here, you don't necessarily see the septum because our picture is cut where that septum would be, but nonetheless you can actually see into the nasal cavity, and you can see how this nasal cavity is actually divided into these different folds. And up at the top here is where you're going to have your olfactory senses, but all throughout the nasal cavity you're also going to have a lot of mucus, and of course through the nose itself you have different hairs and things like that. And nose hair and mucus, they are not just there to uh, make our lives miserable when we're sick or something like that. They have a purpose, and that purpose is to act like a filter, basically. Just like your air conditioner has a filter on it to filter out dust and different particles, so the hair in your nose is going to filter that out, as well as the mucus that's in your nose. Not only that, but that mucus is also, because it's moist, it's going to help moisten that air as it comes through. Think about, again, it's kind of hard because we live in Florida where it's really humid and there's already that moisture in the air. But think about living in a dry, arid environment, somewhere like Arizona where it's not going to get a lot of water in the air. The air that you breathe in is going to be dry. And I can tell you from experience that uh, if you're breathing through your mouth a lot, your mouth is going to dry up very quickly, and it's also going to start to dry up some of uh, your pharynx and your trachea, and that's not something that you want to happen. And so that mucus that's in our nasal cavity, as we're breathing through our nose, even if we're in a dry environment, that mucus is going to help to some extent to help moisten that air, uh, dampening the effects, if you will, of desiccation within the respiratory system. So the nose itself, or the nasal cavity, empties out, it actually drains out into what's known as the pharynx, or better known as our throat. Now, the throat is just simply the back of the um, oral cavity where the nasal passage meets the mouth itself, and there's going to be a section where you do have mixing of air and food and liquids that come into the body, and this section of the pharynx is what's known as the oropharynx and leads down to the laryngopharynx. So our pharynx itself is actually divided into three areas, starting at the nasopharynx, where uh, we start to kind of see the divide between the nasal cavity and starting to get into the actual throat. Then it leads down to the oropharynx, which is where it's right behind the mouth. And then the laryngopharynx is the bottom region that actually goes to the larynx. Again, if you kind of look at these, nasopharynx, the nasal cavity, oropharynx, the oral cavity, the mouth, laryngopharynx, where the larynx is at. So the regions of the pharynx themselves are pretty self-explanatory in the sense that they kind of explain where they're at. And so this diagram here just kind of shows you, it divides these. Our nasal cavity is here. And again, if you have sinus drainage, let's say you have really bad allergies or you have a cold, and you have an excess amount of mucus that's building up because your body's trying to fight off that infection, it's actually going to drain down through the pharynx, which is what can also sometimes give you that sore throat because of that sinus drainage that goes down through the nasal pharynx and into the the oropharynx and the laryngopharynx, which are these two regions here. And again, if you look at this one, this diagram, you can also see here's our tongue. Our tongue is just a muscle that's actually attached to the bottom of our jaw. And so our tongue can't go out too far, but again, you're going to have food and water that's going to come through the mouth, and it gets swallowed through the oropharynx and down into the laryngopharynx. But food should never necessarily go through the nasopharynx. If for whatever reason though, let's say you're eating really fast and you are just eating and trying to breathe and do all these other things at the same time, sometimes food can get pushed up into the nasopharynx, and the only way it can get out is if it just drains down, or if it's pushed, whether by you blowing your nose or whatever, all the way through the nasal cavity and out the nose, which is extremely painful because this area is very sensitive. And trust me, it does not feel good. Another thing you'll notice before we move on from the pharynx are these two tiny little structures here. These structures don't necessarily have anything to do with the respiratory system, but they do have something to do with the lymphatic system, which is our immune system. These are the tonsils, and the tonsils are just areas where some of those antibodies are stored and different things are stored for helping with our immune system. And so when people are talking about getting their tonsils out, these are what they're talking about, these tonsils right here. All right, so the pharynx itself then, again, air is going to come through the mouth and through the nasal cavity, but as it comes through the nasal cavity, it's going to be filtered by those hairs and that mucus, and it's going to get dampened. That dampening is also going to help that air to drop in the sense that it's going to lower through the pharynx, and as it goes through the pharynx, it's actually going to move into the larynx right here, this tube. And so you notice that there's actually two different tubes here. The esophagus, which is the one that our food and water goes down, and then the larynx, which is the one that only air should go down. And so this larynx itself is also what's called our voice box. In fact, if you watched that portion of the endocrine video where it talked about the castrato, the guy who was the singer who was castrated to make sure that his voice stayed high, the reason that worked was because the testosterone never affected his larynx to enlarge that larynx to give him that deeper voice, because it's in the larynx that we find our vocal cords. In fact, that's what that Adam's apple is. So you can even feel it, whether you're a male or female, everybody can feel they have an Adam's apple. And in fact, go ahead and just put your hand right there right now and then try and swallow. And you'll feel your larynx actually move. And what's happening is as you are swallowing, that swallow or reflex, something else happens. You have a little flap that's going to close onto your larynx known as the epiglottis. And what this epiglottis does is it's like a little trap door that makes sure only the right stuff goes down the right tube. So if you've ever heard somebody maybe they're eating something or they're taking a drink and they start to cough really loud, and you ask them if they're okay, and they say, yeah, it just went down the wrong pipe. They're uh, not actually wrong about that, because in the sense that what's happening is as we drink or swallow, uh, this little flap right here should close. That's our epiglottis. And as you notice here, that's exactly what happens. So the larynx moves up and the epiglottis closes over it to make sure that this fluid does not travel down the larynx and into the trachea, but it keeps going down the esophagus instead. And that's extremely important, because if we were to have those fluids that were to slip past this epiglottis and get into the larynx, uh, not only will we start to cough on it, but if we had enough fluid that started to get down that way, that could be what leads to pneumonia. Again, pneumonia is actually when the lungs are filling up with a fluid, and if the lungs are filled with the fluid, they can't do their job to recycle the air, and so it's an extremely dangerous situation. Likewise, if somebody, let's say they're not drinking something, but let's say that they have, say, swallowed a piece of steak that they didn't chew all the way like they should have, and it got stuck right here. Well, now it's completely closed off the trachea, so there can be no airflow. And so that's what happens when somebody starts to choke on their food. What's actually happened, it's not that it's in the esophagus, but that it's gone down the wrong pipe, in the sense that it's now stuck in between the epiglottis and the trachea, or the larynx. And so that's why you'll see people give the Heimlich maneuver, because what the Heimlich maneuver is going to do is it's going to squeeze and push as much air through that trachea as possible to try and basically push whatever is blocking the passageway out. And that's why you'll see people, like, they'll, like in a movie or something like that, when they're doing the Heimlich maneuver, and they'll spit the food out and it just goes flying, because of the pressure behind that push, and that's the reason why. So the larynx itself is just kind of the passageway down into the trachea, but at the superior portion of the larynx, we find these two little folds, and these folds are our vocal cords. And if you remember back when we were talking about the senses, we talked about how sound is made, or what sound is. And we talked about how sound is just simply vibrations that are traveling through the air. And we can change those vibrations to give different sounds and pitches. Think of a guitar for an example, or just any musical instrument where you're going to be moving your, or any stringed instrument, you're going to be moving your fingers across the strings, and depending on where your finger is at, it's going to change the vibration of that string, changing the sound. It's the same way with our vocal cords. And so when we stretch our vocal cords out to make them longer, we're going to get like a higher pitch. When they're shorter, we're going to get a lower pitch. And there is uh, a really interesting video about this. This is what your vocal cords actually look like. This is a video where a doctor's put like a little camera down somebody's throat and ask them to sing a few notes and to say a few things, and you can actually see how the vocal cords will change depending on the pitch of the person and what task they were asked to do. And you can see how the air passing through the vocal cords, and as those vocal cords vibrate, it makes a sound. And so again, I highly recommend go ahead and watch that video, and I will have the link for that in the description below. So the larynx itself, our Adam's apple, our voice box, leads down into the trachea. The trachea, it's about 4 inches from where our Adam's apple is at to where our lungs actually begin, or where the bronchi, which singular would be bronchus tubes, are going to divide off into the different lobes of the lungs. So this trachea itself is a tube that's made out of a C-shaped cartilage. And what do I mean by C-shaped? It's literally in the shape of a C. It's not a completely round tube, because if you'll notice, our trachea is attached to another tube. This is our esophagus. This is the one that the food is supposed to go down. And so, looking back at our picture here, again, you can see here's our trachea. This is the portion that we're talking about right now. Right behind it is the esophagus. Now, having this cartilage here, having this tube made out or reinforced with that cartilage works for several different things. First of all, it's going to give the esophagus some extra support when we're swallowing food. But even more important than that, because it's this cartilage, depending on whether we're breathing in or breathing out, or even if we're eating, it really doesn't matter because it's going to retain its shape. In other words, this tube is not going to collapse in on itself. It's going to retain that shape. That way we can constantly be breathing in or breathing out, and it's not going to fluctuate with our functionality of it. And so that's why it's made out of that cartilage. The best way that I could describe it is if you've ever had like one of those cups from like Busch Gardens or SeaWorld that has like the really rigid straw, it kind of reminds me of those rigid straws. And so within the trachea, though, there are these ciliated cells. And if you remember what cilia are, those are like the little tiny hair-like structures on the ends of certain cells. And these cilia work just like the hairs in our nose, and they're going to be helping with filtering debris that maybe made it past the nose and the pharynx. And it's also going to be helping because these ciliated cells are what are known as mucosa. In other words, they're going to be making a mucus layer that's going to, again, keep our trachea nice and moist for the air that's going into the lungs, which you can see here. So again, these are all like the ciliated cells. And so the last thing we're actually going to be talking about today is once that air travels down the trachea, it's going to enter into the lungs. And if you notice here, you see their lungs are actually divided. Our lungs aren't just two big sacs that are going to be taking in air like we're often led to believe, whether in cartoons or just in misconceptions about the lungs. They're more like a spongy material in the sense that they're filled with all these little porous holes, or not holes, but these sacs that are known as alveoli. And in between those sacs, it's actually, a firmish tissue. We can also see that our lungs aren't one complete lung in the sense that it's a fully fused organ. They're divided into lobes like other organs as well in our body, between these fissures. So just like our brain has fissures, our liver has fissures, and in between these fissures are the lobes. And so we have 3 lobes on the right lung and 2 lobes on the left lung. And these lobes, again, like I said, our lungs aren't just sacs that are going to inflate and deflate with air. There's actually a network of tubes and branching air sacs within the lungs that are actually going to be doing the job. And so sometimes it's often referred to as like a little upside down tree. And you can even see that in this picture here with the bronchial tubes. And so as we go down and we leave the trachea, right about here, you would start to see the lungs right about in this area. And so imagine, if you will, that this area has the lungs here, but we're just looking on the inside. So as the trachea starts to divide into the right and left lung, we divide into these areas known as the bronchi or the bronchi. And plural again is bronchi, singular is bronchus, but we have these two main bronchus tubes, the right and the left. And they're what's known as the primary ones. And then in the lungs, they're going to split again. That split is then what's known as the secondary bronchi. And then guess what? Those secondary are going to split into tertiary bronchi. And then those tertiary bronchi are going to split again, so on and so forth, until we get to these tiny little tubes known as the bronchioles. And it's these bronchioles that are going to be like the smallest little tubes that we have that will lead to like these little terminal bronchioles that are the ends of our bronchial tubes, our little tree, if you will. And those terminal bronchioles are going to end in what's known as the alveoli, or these air sacs. And we're going to leave off here for today, and we're going to talk about these tomorrow. But as you can already tell, looking at the arteries and veins that we see here, this is where we're going to get that diffusion of oxygen and carbon dioxide going on the whole process of the respiratory system. So, what we talked about today, we talked about all the different organs or the structures that are involved within the respiratory system. We discussed the nose, the pharynx, the larynx, the trachea, the bronchi, and we just start to discuss the lungs and the bronchial tubes that are like the little upside down trees that are in here. And we left off on the alveoli, and that's where we will start tomorrow. So if you have any questions, go ahead and let me know through Remind, and I will talk to you later.